Next question. Jack is playing a board game in which he needs to throw a 6 with an ordinary die in order to start the game. Find the probability that exactly 4 atoms are needed to obtain a 6. B. At least 2 atoms are needed. C. He is successful in throwing a 6 in 3 or fewer atoms. D. He needs more than 3 atoms to obtain a 6. We are going to start the question by let x be a random variable. X is the number of atoms up to and including the first occurrence of a 6. That is, Jack needs to throw the die until he obtains a 6. The probability of obtaining a 6 is 1 over 6. So using a geometric distribution with P 1 over 6 and Q 5 over 6. So from P we obtain Q 1 minus 1 over 6, which is 5 over 6. We have the geometric model X follows geo P. P is 1 over 6. Exactly 4 atoms are needed to obtain a 6, which means that R is equal to 4. We need to find probability of X is equal to 4 equals P, which is 1 over 6 multiplied by what? Q power 3. 5 over 6 cube multiplied by 1 over 6. We have 125 over 1296, or in decimal form we have 0.0965. Second part, you're asked to find at least 2 atoms are needed. Probability of at least 2, which means X is greater or equal to 2. At least 2 atoms. It is the same as 1 minus probability of X equal to 1. That the geometric model starts with 1. First experiment, second experiment, third experiment, and it goes on. So at least 2, which means 2 or greater than 2. So which number we do not want? 1. So 1 minus the probability of X is equal to 1. So we're going to have what? 1 minus P. We've seen earlier that the probability of X is equal to 1 is what? P. We have 1 minus 1 over 6, which is 5 over 6. He is successful in throwing a 6 in 3 or fewer atoms. So we need to find the probability of X is less or equal to 3. So it's going to be the same as what? Less or equal to 3. Probability of X is equal to 1 plus probability of X is equal to 2 plus probability of X is equal to 3. We've seen previously P of X is equal to 1 is P. P of X is equal to 2 is QP. P of X is equal to 3 is Q square P. You replace the value, you get to 3 significant figures. Or we can simply use the results that we have seen previously. Probability of X less equal to X is the same as what? 1 minus Q power X. Or alternatively, we can use the first result, which is probability of X less or equal to 3 equals what? 1 minus Q 5 over 6 power 3. We have the same answer, which is 0.421. Part D, He needs more than 3 attempts to obtain a 6. So we need to find what? Probability of x more than 3, greater than 3, which is the same as what? 1 minus probability of x less or equal to 3. We have 1, 2, 3, 4, and so on. So we need greater than 3. Greater, so we need more than 3, greater than 3, which means that we do not need 1, 2, 3 included. So we're going to take 1 minus probability of 1, 2, 3 to get this. 1 minus, we have already calculated this probability in part C, which is 0.420 0.579. Or we can simply use this formula, greater than 3. So greater than 3, we simply take 5 over 6 power 3. And alternatively, we can use 5 over 6 power 3. We have the same answer as. I hope it is much clearer now. Let's tackle another question on geometric distribution.